A good day to you, Calc 3. Today we're going to really quickly talk about what is R3. So this will be the first video, and hopefully many videos to come, as an explanation for the things that we've been learning in class. So in our breakout section, we've been learning some supplemental materials, and I think it's good that we brush up on and expand upon some of the ideas brought up in class. So the first thing that we're going to talk about is what's called the number line. This is something that we've been dealing with since we were very young. On the number line exists 0, 1, -1, and all the numbers in between. Okay? And that's great, and you can play there for a while, and you can plot numbers on it, you can figure out distance. But eventually, we run into a problem where we need to extend our thoughts not only in one direction, but in two. And then, right around middle school, we decided, well, we need something that has an independent and a dependent axis, right? Something that we call the domain, and something that we call the range. And then we said that this number line, the domain, maps onto this number line, the range. From this, we were able to build things like functions, parameterized curves, and many, many, many great things. And we called that plane R2, which is what's called the Cartesian product of two real lines. That's where we get the R2 from. We're going to soon learn about what's called the cross product. This is not the cross product. It's what's called the Cartesian product. It's a set operation because you're dealing with two sets, not two vector elements. Now, the way the R2 is formed is we take our one number line, right? And then notionally we're able to have it go infinitely up and infinitely down. And in doing so, we create what are called ordered pairs, which is basically saying we have this number line right here, where we have something like a 1, and then we go up 2 on our second number line, and we have the ordered pair 1, 2. Okay? So if we added one line in order to go from R1 to R2, stands to reason to go from R2 to R3, we have to add one more line. Now, how are we going to do that? Well, if we were to build our plane as such, where we have our x coordinates and our y coordinates, where we have two real lines, if we were to create a third line, we can call the z-axis. And this is a third real line. That's what's called orthogonal to the x, orthogonal to the y, and orthogonal to the x-axis, which is to say that we have 90 degrees. Now, instead of going from a plane, that is this whiteboard, we have something that now extends out of our plane to create 3 dimensions. And we call this coordinate space R3, which means we have the ordered pairs in x, in y, and in z. So for a point, say 1, 2, 3, as you'll soon to come to find, these are my favorite ordered pairs. We're 1 out in the x direction, 2 out in the y direction, 3 up in the z direction. Okay, now that we've built that, we can think about how that R3 was created. And the whole idea is that we have this plane right here, which we know as R2. And it's able to move up, and it's able to move down. Now, there's something we do need to know. When I created this plane and let it have one more degree of freedom vertically, and right? I didn't describe where it stands. And that is to say, if I were to have declared the z y plane to be my R2, and let x be my third degree of freedom, that'd be equally fine. We simply let this plane move forward and backwards in x direction. And similarly, you can do the same thing for the z and the x direction. So with that bit of information in mind, I hope this aids in your process of actually graphing functions in 3 space. Watch the next video where we actually plot some functions.